In this example, we want to find out how long does it take for an investment to double in value if it's invested at 8% compounded continuously. Okay, so first thing, we want to make sure we're talking about compound interest. We want to make sure we're using the correct formula. So it tells us compounded continuously, so we want to use A equals P times e to the RT. Again, it will always explicitly say the word continuously if you're using this formula. Otherwise, for compound interest, you would use your P times 1 plus R over N to the NT. Okay, so first of all, we're asked to solve for how long. So in this case, we're asked to solve for T. Now, it's talking about the investment doubling in value, and it's invested at 8% compounded continuously. So we know we have our R of 0.08. Now, as far as doubling in value, we don't have a specific initial principal amount, but it doesn't matter. So we can pick any amount that we want for the original principal and then just double it. So for instance, we could choose a principal of $1, and then double it and get $2. We could choose an original principal of $50, so then in order for it to double, it would be $100. Or if we just choose a generic P, if I double that principal P, I'll have 2P. So I could substitute in 2P for that A, and then I'd have P times e to the RT 0.08T. So again, you can use a generic principal P, and then if it's doubled, it's 2P. But then we see that we can divide out here those common P's. So we'll just have 2 equals e to the 0.08T. But again, you could do any example. If you put in, let's say you started with $50, 50 e to the 0.08T. If you double the 50, that would give you 100. Well, if you divide both sides by 50, you're still going to be left with, on the left, a 2. Those 50s would divide out, and it's e to the 0.08T. So if it's talking about doubling or tripling, you can pick whatever you want, or just pick a generic P, and then put 2P for doubling, or 3P for tripling, etc. Now this equation should look familiar. We've got an exponential equation, an equation where the variable appears up in the exponent. So we remember we've got two methods to solve these. We can try to write both sides with the same base if possible, but since we've got this e here and a 2 here, that's not going to work. So we remember we're going to use logs. So if I convert this to logarithmic form, if I'm talking about a base of e, I know that that's natural log. So I'm going to use natural log of that 2, and remember the log is always equal to the exponent, 0.08t. So I'm just writing that in equivalent logarithmic form. And then I just divide by that 0.08. So if we enter that into the calculator, we're going to get approximately 8.7 years. That time is always in years. So no matter how much you invest initially in this account, since it's 8% compounded continuously, it will take about 8.7 years to double that amount.